Hello, my name is Munib Jaamoos. Today I'm going to be discussing about my project, which is an automated irrigation system. This system relies on the Penman-Monteith equation. Now, the reason why I made this device is because of the fact that Jordan is the second most water-scarce country, and it relies heavily on its agricultural sector. In addition to this, it has been found that 70% of the world's water is used for agriculture, and 40% of that water is wasted during the process of irrigation. Because of this fact, and that Jordan relies heavily on its agricultural sector, I decided to create this device in order to reduce the amount of wasted water when it comes to irrigating the plants in our country. Now, let's talk a bit more about the device itself. Now, to talk more about the device itself, first of all, we have a solenoid valve here. This solenoid valve is responsible for controlling the water flow when it comes to control the water flow of the device. Next is a water flow sensor. This will act as a totalizer in order to measure the amount of water that is being released from the tank. In this case, the bottle will be our tank. Next, we have a humidity sensor. It is right here. This humidity sensor will measure the humidity of the soil in order for us to find out if the soil is too humid for the plant or not, or that if it doesn't have enough water for it to be comfortable for the plant. So once we water it, we would know in advance if it's going to be oversaturated or if it needs a bit more water to ensure that it isn't too dry for the plant. Now, when it comes to the component that's controlling the entire thing, it is an Arduino Mega. I use an Arduino Mega over an Uno is because of the fact that an Arduino Mega has more pins and has a large enough storage capacity for what I need it for. And we have an LCD display in order for the user and the device to communicate with one another. Now I'll turn on the device. We will first see it count down. Once it begins, we'll turn on our pump, and this pump will begin releasing water towards the plant. And once, usually the quantity of water would be a lot more, but for demonstration purposes, we just use this much. As you can see, it's right now measuring the humidity as 93%. Because of the soil being already humid and the amount of water we just released being already too much for the plant itself. Now the test is complete. Seeing it ran out of water. Now to talk more about the Penman-Monteith equation and how it works and why I chose it over traditional irrigation methods. First, define traditional irrigation methods. Traditional irrigation methods are when a farmer uses his experience and what he sees as what works best when it comes to watering the plant over precisely calculating how much water a plant would need. While the Penman-Monteith equation takes in weather parameters in order to find out the rate of evapotranspiration, which is the amount of water that is being released from evaporation and transpiration. The variables include things such as solar radiation, the wind speed and temperature, and among other factors. But one factor we couldn't measure here was the soil heat flux density, because the tool required to measure it is unavailable in the country. So we just assumed to be for it to be zero, seeing that is how many other research papers that wanted to test out the formula assumed it to be. Now, when it comes to how the device itself works and takes into account the Penman-Monteith equation, first of all, it will check if the soil humidity is too low, usually being 35%, seeing we found 35% being the usual point in which the soil humidity is comfortable for the plant. If it is, it will compare the current humidity between the current humidity and the 35%, and it will increase it by it will pour water by that amount. Next up, after that, it will wait a certain amount of time. Once that time is over, it will water the plant normally based off of the Penman-Monteith equation. The Penman-Monteith equation will divide the water up into four times per day. So 100. So let's say 100 liters will be divided into 25 liters, 25 liters, 25 liters, 25 liters throughout the day. But if it's oversaturated, we'll wait until the difference between the current humidity and the maximum humidity decreases, in order to ensure that the soil humidity is to ensure that once we water the plant, the soil humidity wouldn't be too much for it to handle. That is all about the device.